Welcome to the Blockchain-Enabled Space Traffic Awareness presentation, otherwise known as BESTA. My name is Harvey Reed of the MITRE Corporation, and I am joined by Robert Carden, also of the MITRE Corporation, and we're pleased to be here at Ascend 2020. We're going to start by noting that there's going to be two main topics covered in this paper, and they work together. One is STM information sharing, space traffic management information sharing, and then we're going to have a little bit of a deep dive into sensor observation data, which is part of STM information. And we're going to be covering topics related to blockchain and how decentralization plus secure data with the blockchain can improve STM information sharing from the sensor level all the way up to the international adjudication layer. And the point really about STM is that it's becoming, the space as a domain is becoming increasingly congested, and if we want to increase STM automation to maintain safety, we require automatic discovery of anomalies for adjudication and COAs. And present day, that's very difficult. To support increased automation and automatic discovery of anomalies, we require trusted data in the form of the most recent observations and also the most recent agreements, so they can be compared to discover the anomalies. Next, Bob will talk a little bit about sensor observation data. Over to you, Bob, on slide 3.
Part of that environment that Harvey is laying out requires that we change our mindset about sensors and how we think about the data. We need to get as much data, maximize the information gain coming off of those sensors. We need that data to come in a timely manner for decision space. And then we need to have a sensor system that's flexible enough to update either any number of sensors or any phenomenologies of sensors such that you could envision a global sensor network that did not care who was talking to it. One of the nice things that working through a blockchain technology does is it gives us that trust in an untrusted environment, so we can start to do that, and we can totally exponentially improve the amount of information coming off of the system. That will feed systems like BESTA into the future much better than the current systems that we run.
And now we're going to go back to the information sharing, and keep in mind that increased STM automation, discovery of anomalies, that requires good STM info, such as sensor data, and that's why these two topics are paired together, and such as STM agreements. So, for example, within BESTA, the main concept is how do you do the matches? You have to have those two inputs, and then theoretically we can detect differences of a certain threshold that will trigger a detected anomaly. And the consideration is that decentralization and use of blockchain at a minimum would provide attribution, provenance, and resilience, data security. Next, on slide 5, we can zoom out a little bit from BESTA as a concept, and we can see the STM stakeholders using the BESTA module, both to provide inputs. They could be STM info, such as sensor data. It could be agreements, such as what's the plan for the satellite, what orbit and frequency. And then once the anomaly is detected, the STM stakeholders also have a stake in that game too, because the anomaly needs to be resolved by somebody changing their orbit or some other characteristic about in-orbit operations. So stakeholders could use the BESTA to, again, to repeat, to both provide the input data and then to also benefit from anomalies being detected. And because of the way that, at least in this BESTA concept, the way that the data would be securitized from the point of view of using cryptographic techniques of blockchain, then it would be suitable, we think, for the international community. On the next slide, on slide number 6, we can zoom inside BESTA and see what pieces might there be inside. And then on the input side, for example, the SSA, the Space Situational Awareness info, that input would be ingested and the provenance recorded on a blockchain so that we could tell for every piece of STM info, SSA info, that data has some provenance associated with this. And whether it's that information is then shared out again as a reconciled feed or input into a comparison module, you'll always be able to go back to the blockchain and say, well, who sent that information and when, and different particulars like that. And then on the STM agreement side, the same thing. You want to be able to record the provenance. You want to be able to have that as input to a comparison module. Once the comparison module gets the inputs with provenance, then comparison can happen, and if an anomaly is triggered, then evidence preparation can take place, and that is where you grab the parts of the STM information feed that's relevant. You can copy that in. You can also copy parts of the relevant agreements and prepare an evidence package and have that secured by the blockchain as well. And then the next thing that would happen is anomaly adjudication workflow, where again, you could track activities using the blockchain, and this prevents people from trying to game the system or perhaps spoof or maybe even as defense against other sophisticated types of cyber attack. On the next slide, number 7, we can see that in addition to the blockchain being used to record provenance data and be able to secure data like that, there's also an aspect of blockchain that's very important and very useful for the sensors, which is the peer-to-peer information sharing. So for example, the current SSN, excuse me, space sensor network uses a central intermediary pattern that you can see on the lower left-hand part of the diagram, where you have a central intermediary, and in that case, all the sensors report directly to the CSPOC. Other types of legacy information sharing patterns would be everybody send a message to everybody else and try to keep in sync that way. The central intermediary model usually has problems manifested in terms of time delays. In this case with the SSN, just a general information gain problem. Looking to do is to explore decentralization and see can the decentralized aspect of the blockchain help on the sensor end. So keep in mind the decentralization use of blockchain, it's not only for attribution, availability, and trust, but also for peer-to-peer information sharing. So over to you, Bob, on slide 8.
Sure. So one of the concepts that we've investigated to do that decentralized resilient networking is called SNARE, Sensor Network Autonomous Resilient Extensible. And this is a MITRE developed system that essentially is a autonomous sensor tasking technique tied to a blockchain to record the most current positional state and provide change detection on tactical timelines. Ultimately, this is a real-time NP-hard problem solver that uses the blockchain to record the state of the problems. In this case, it is observational state of the position of things in space. It is running continuously. The sensors schedule their own collection based on the last published state of the object in the blockchain. The centralized node in our current system simply becomes a node on the blockchain, and it allows it to see the states of the objects that are being collected. And using a priority schema, you can publish a state requiring a higher priority to achieve behavior from the network that gets you to the information gain for given objects you're looking for. Ultimately, blockchain gives this type of a network resiliency and agnosticism for data that allows many different types of sensors to publish and consume data off of the system. So SNARE, basically, like I said in the previous slide, is an algorithmically driven collection schema that uses the data on the blockchain, the positional states published to the blockchain, for activity. The sensors see a published state and they go through and they ask some questions of themselves and report that back to the system. If a state publishes a sensor, will look at that state, determine whether it can even see it or not, determine when it can see it and when it can see it next and how well, and then also look at what it was going to do at that time, its regrets count, so that it can make some value decisions about the collection value that it would contribute to the network. All the sensors who can possibly see that object at any given time are making this economic determination of value collection, and SNARE consents to the sensor with the highest collection value collecting on that object. Ultimately, we end up with is a near real-time continuous system that is based on the trusted and available information that is published to and from the blockchain. And one of the interesting pieces to this is that the amount of resources in the experiments, the amount of resources that are used to achieve higher information gain than current methods of a centralized C2 system tasking things out was considerable. And that resilient, autonomous, real-time collection system reporting to something like BESTA makes for a really, really interesting combination, so that data can be used by those adjudication systems in a comparative engine for anomalies and detection of those anomalies. Last bit on SNARE. As a sensor, it has value, but in an architectural network, the integration of other sensors that we don't own, can't capitalize, can't afford to buy, but we could use their data. SNARE gives you a method to do that. It also allows you to include non-traditionals in a plug-and-play mode and to trust them in an untrusted environment, so that you can take advantage of all the sensing capacity out there that you potentially can't afford to simply go buy. The decentralized blockchain allows that to happen amongst those non-trusted sensors who are not owned by the government, and it also allows that rapid onboarding process with a SNARE node, because the integration is hours and not weeks and days. Over to you, Harvey, for how we would plug that into the larger BESTA architecture.
Okay, thank you, Bob. On the next slide, on number 11, we can see the larger picture if we zoom way out. And before we dig into this too much, one additional note on the SNARE architecture. As Bob said, it was very modular, and the blockchain, not only does it secure the data, attribute it properly, enable peer-to-peer information sharing, but because of the nature of the blockchain technology itself, it allows for the introduction of new nodes in a very short amount of time, and that becomes the focal point of integration. So you avoid the necessity for everybody to update ICDs and things like that. Simply, you plug the new sensor in associated with the blockchain node, and then the sensor will be reading and writing data, making it information-centric as opposed to standalone-centric or platform-centric, where the information sharing conduits are typically a little bit more hard-coded than that. This gives you a way to have plug-and-play architecture, as Bob said. So looking at this information sharing stack, we can see the SNARE concept as a candidate replacement for the SSN. Prototypes already in progress. That provides a near continuously updated feed of information, which, as Bob said, ultimately makes its way up to BESTA. From the US perspective, that information would go first to the OADR, the Open Architecture Data Repository operated by Department of Commerce, who may also want to augment that data with commercial observations. So the SNARE architecture itself can include additional sensors, and the OADR may opt to also augment with additional commercial observations. And then as a national feed, the Department of Commerce would feed BESTA, as well as other countries could feed could send their national feeds up to BESTA as well. So the purpose of this diagram is to show that in effect forms a supply chain of SDM information going up to the BESTA level, which can then grind on the comparisons and kick out discovered anomalies. Further, it also serves as a talking point to show where decentralization can improve the architecture and information sharing at each level. So for the sensors, we saw that the decentralization helps the information gain and the timeliness. At the augmented national feed, we can use blockchain to help run auctions, perhaps, to help the OADR maximize the utility of commercial readings, which Bob will get into more when we talk about research. And then at the BESTA level, the blockchain can help definitely, locking down evidence and taking care of the provenance of the information feeds. So over to slide 12, we can tie the presentation up by offering perhaps a couple of items, food for thought for people doing research and setting agendas. So on the BESTA side, one topic would be research into discovery. So what does it mean to automatically ingest agreements and do the comparisons? Well, ultimately, this has to boil down to machine-readable ontologies. And we're talking about, RDF and Sparkle queries, things of that nature, or an equivalent. It doesn't have to be, that exact OWL-type ontology. And so how can we best do comparisons to be able to automatically detect anomalies? And the other one is evidence capture and secure storage. There's certainly research to be had into decentralized file systems and, what are the repositories that are going to support BESTA? So all the data is not going to go into blockchain. Obviously, we would have pointers to off-chain storage, which could be in decentralized file systems. And Bob, what ideas do you have for research topics on SNARE?
Sure. So as SNARE starts to become the evidentiary basis for something like BESTA, it could also be the basis for a market-based collection scheme that gets put out to an open market, as it were, of sensor systems that don't belong to us that could potentially collect and provide information gain on those requirements. And also the sensor placement and procurement tool, where you could look at loss or less than optimal information gain on objects around the planet based on the physics of location, to be able to say, to add the most bang for the buck in terms of a new sensor placed somewhere on the planet, this is where I would put it, and you could run that through the SNARE algorithm to make sure that that decision was going to provide the highest information gain possible. Those are the two that we would suggest going forward.
Okay, thank you, Bob. And we're going to close out on slide 13 by saying we appreciate your attention very much. We invite you to read the full paper. The full paper is a mere 14 pages, and you can see our email addresses here, and please contact us if you have any further follow-up. Thank you very much.